Jain to all. Welcome to my video. I am Saminder Singh, Assistant Professor in the Department of CSC, AKG EC, Ghaziabad. I have taken compiler design, and today session I will discuss about what is compiler construction tool. It's a complex topic. Before telling anything about compiler construction tool, we have to know knowledge about what is translation process, what is phases of compiler. In all, we have at least a knowledge about what is compiler. So we are start with compiler, then phases of the compiler, and during each compilation these topics should be clear. Let's start. What is translation process? So translation simply means it's a process consists of a collection of phases the translation process, then it's a collection of phases with the output of one phase feeding the input to the next. That means we have a number of phases of the compiler. Let's see what these phases are. So these are the block diagram of the compiler, in which we divide the compiler in number of phases. So first phase, it is a lexical analyzer. After that we have syntax analyzer, then we have semantic analyzer, and then intermediate code generator, after that code optimizer, and in the last we have code generator. This is all the phases of compiler. All phases are connected with two data structures. First is symbol table manager and second is error handler. Before telling about these phases, first we talk about what is compiler. You know very well compiler is a translator that translate high level language into low level language. What is high level language? As you all are belongs to CS background, so you know about high level language, that these are like C, C++, and any other programming language in which a user or we can programmer feed their request to the computer for a particular task. So this is high level language, but in this language computer unable to understand that language, so we need a language that is understandable by the computer. That language is low level language. So we need a program or a tool that translates this language into low level language. This task is accomplished by a translator that is known as compiler. So compiler is a translator that translates high level language into low level language. No meaning change, no task, no, and no, we didn't have any change in our initial input that we are going to feed. Since we are feeding a request for a particular task and we need output of our request, our problem that we are going to solve by means of computer. So to convert this language we need another translator, that is compiler. I hope you can understand the working of compiler, a task of compiler. Now task is clear. Now this compiler is divided into number of phases. First phase is lexical analyzer, then we have syntax analyzer, then we have semantics analyzer, then it's intermediate between these phases. This is intermediate code generator, after that code optimizer, then code generator. and finally we get the required target program. And these all phases are connected to two things. First is symbol table manager and second is error handler. So I already told you about one major function of the compiler, that is conversion of high level language into low level language. And second is also a major function of compiler, that is if we have error in our program, that is also picked by a compiler and encounter and highlight display to the monitor console. That duty is also done by compilers. So that thing is going to is covered by error handler. So error handler are doing any error, whether it is in first phase, in second phase, it is in third phase, or in any phase. So if compiler found any error in its any phase, then it encounter and display it onto monitor. This is done by error handler. So these are. Now we will discuss each phase in detail so that you can easily so that you can easily clear about the working of compiler. Let us start the first phase. Scanner. So this is our scanner or first phase. In the block diagram, first phase is lexical analyzer. This is same scanner. It is the second name of lexical analyzer. So scanner reads the source program as a stream of character and it performs lexical analysis, collecting sequence of characters into meaningful units called tokens. This is first function. And second is the scanner also may create a symbol table and a literal table. So these are two functions of the first phase, that is lexical analyzer. Let's understand it with a simple example. Suppose we have a statement A plus B into D. Suppose this is our code. Yeah, it's a program that we are going to feed into the computer for processing. So it is going to convert in low level language. So as an input, it is the main input of the compiler. So it goes to scanner, first phase of the compiler. And what the scanner do? It reads the source program as a stream of characters. Means it reads this from left to right, scan this. So this is scanning. So it gets first symbol, that is A. Then second symbol, third symbol, fourth symbol, fifth symbol. So then it collects this. Suppose I am collecting these two. Is it a unique meaning? No. So after one symbol is checked, second symbol, it is able to group it, but in this case these are two different things. This is character and this is a operator. So scanner will depict this one. So and it is our first stream of character, or we can say collecting sequence of character that has a particular meaning. So this is first token. In the same way, This is our second token, then third token, then fourth token, then fifth, then sixth, then seven. So in the given example, we have 7 tokens, one by one. The first is name of identifier. So first is identifier, that is A. Then we have operator, that is assignment operator. Then we have second identifier B. Then we have third identifier C. We have addition operator, and we have fourth identifier D, and lastly we have multiple operator. So these are the number of tokens that are gathered, that are collected by scanner or lexical analyzer. This is first task. First. Then second, scanner also may create a symbol table and literal table. In the block diagram, we have a symbol table. So what the symbol table do? So simply this scanner will save these number of tokens into that symbol table with their respective information. Like this is A. So what is the type of this one? That is an identifier. So A is stored in symbol table along with its all properties, attributes. This is also a duty of scanner, or we can say lexical analyzer. So scanner will store these 4 identifier in symbol table as well as these 3 operator in symbol table. So these are the 2 responsibility of first phase of the compiler. As an output, what we have? As an output, we have 4 identifier, 3 operators. Okay. So come to the next, second phase. This is parser, or we can say this is syntactic analysis. We are going to syntactic analysis. What is syntactic analysis? It is something that creates syntax hierarchical structure that gives a analysis of hierarchical thing. So the tokens generated in first phase as an input it will go to next phase, that is parser, or we can say it's a syntax analysis. In block diagram, second phase is represented as syntax analysis, which is also known as parser. So as an input, it takes token and it will generate a parse tree. Parse tree. What is parse tree? It's a hierarchical structure of the given code. Since we have example A, B into D. By first phase, we have number of tokens generated, and these tokens will come to parser for further processing. In this phase, parser will do to create a parse tree. So parse tree it's a hierarchical structure. So in the C, these tokens we have 7 tokens as an input in. We then, after processing in the second phase, we got a parse tree that will be a hierarchical structure in which we have nodes, edges. Interior nodes will generally will be represented by operators, and leaves are generally represented by operands, on which these operands that are going to operate by means of these operators. Suppose this one. As this point, we have a value that is C is C multiplied D. Suppose we have value, this is value small a, then in this particular point we have second value that is B plus A. In the same manner, here we have a value that we are assigned this value right child. So right child we have a value A to A B plus small a, that going to assign with capital A. So this is what we are representing in the second. So basically it's abstract syntax tree, a reduced representation of the tree with many irrelevant node elimination. This is all about parsers. Let's go to third phase of the compiler. This is our semantic analyzer. It is similar to the previous one, but have a one first we have semantics of a program or its meaning, what it is intended to accomplish. Means in the given parse tree, each node, suppose this one, in the last example we have so this is the parse tree that is generated by second phase and will be input to the next phase, that is semantic analyzer phase. So in the semantic analyzer will check all the nodes, suppose C and D, is these are the compatible with respect to this operator or not. Then if these are compatible with this operator, then it goes to next level, that means there. So again it will check this operand and this operand, both are compatible. If both are compatible, then goes to next level, so on. But if it found that B is not compatible with this operator, then it will encounter an error and encounter an error. So just like this one, suppose we have let's suppose operands, or we can say identifier, which we are going to use in our coding. A and B are of integer type and C and D are of float type. So at this point we are type checking to both the operand. This is float, this is float. Operation can be implemented. So at this point no issue. But the result that we have will be of float type. Now this operator also check both operand with they are valid or not. This is integer type and this is float type, means one is both are different type. So as we know integer is low precedence, so we have to convert this integer into float. So we adding a new node in it, that is int to float, through which we are convert this integer to float. Now this is float type. This is float, this is float. This operation can easily be done. So at this point we have float type. Again at this point, before assignment, both operand will be checked. So this is integer type and this is float type. Again contradiction. Again we have class. Both operands are different by means of their type. So again we have to convert one of them to others type. So what we can do, integer have to convert it into float, so we are doing int to float again. So we are attached one more node to this one to make this compatible to with respect to this one. Now both are of float type. This can be implemented at this point. So we are doing two type checking, found error. If it is possible to rectify that, in this case we are able to rectify. So no need to do anything, just rectify this. So we are attaching a new node. This is known as semantic analysis. First we do semantic analysis, after that we rectify the error and in the same fashion we found complete process. Now this pass tree is different from the previous one. How? By adding new nodes in which we are apply semantic actions. So when we attach another node to the parse tree as a semantic action, so this parse tree is known as annotated parse tree. What is annotated parse tree? So this is the output of this phase. So we can say semantic analysis is of two types. First is static semantic and second is dynamic. Static means before compilation, or we can say it's a simple case, just like checking of type checking and whatever, just what we do in this particular example. This is static semantics. In dynamic semantic of a program only can be determined by the executing the program. During the execution of program, we have number of semantics, that is to be dynamic semantics. An example in this case, example of the static semantics of a program is the data types that we do in the last example of the variable and expression do. Then these static semantics usually are represented in the intermediate representations as attributes. In the same manner we will do, just like for adding a new nodes into flow. This is what the IR usually a tree decorated with these attributes. Okay, here I'm using a term IR, that is intermediate representation, as we have raw program, that is source code, and before convert it into target code, it will go through number of transformations. After first phase transformation, it converted into a stream of tokens. That is our first intermediate representation. After second phase, it will convert into parse tree. This is our second intermediate representation. And after third phase, it will convert it into annotated parse tree, or we can say decorated. Decoration means we are adding new attributes to nodes which we find incompatible by means of their specified rules of any programming language. So let's go for the next phase, that is code optimization. Till now we have three phases. First is lexical analyzer, then we have syntax analyzer, and then we have semantic analyzer. In these first three phases we are doing just analysis. So we can say these first three phases are also known as analysis of the compiler. As an output it generates simply annotated parse tree. In this annotated parse tree, now optimization is start, or we can say transformation to machine code is start there. Now there is optimization when occur during several phases. Source code optimization rearranges the sources. Simply whatever source code we are given, if there is possibility to rearrangement and make our program simpler, that means this is also optimization. Or the IR, this is intermediate representation of the source in order to produce more optimal results. An example, this is X, this is first thing we have to given, that is X is equal to 7 plus 9. We will convert this into this one. Here we can see we have in the right hand side two different constant. To make two different constant to one, now we have only one constant. So this will obviously save memory, and execution time is also reduced. So this process is known as constant folding. Number of procedures we are using to optimize the given code. Now, like duplicate computation can be saved as temporaries and then their value is reused. That means if we find a repeated values, just like suppose we have A is 5, again we have A, we are using A, so we can save it into temporary memory, and this will and then reuse this. Whether we are using again and again this to in our code, we simply save it in a temporary memory and reuse. This is another optimization. Then we have recursion can be converted to iterations. It is a major optimization procedure. Then we have repeated calculations can be moved out of loop. As we know that loops of any program have take the most of the computation time. Inside loop, if we have a computation or calculation, that can be there can be possibility to move that segment to out of the loop. If there is a possibility, then we will do that. To make that change, it will definitely reduce the time. Since we are in loop, we again and again trace that particular segment. But when we move that segment out of the move, no need to trace that loop, trace that point again and again. This, and there are number of possibilities for optimization. Next, final is code generator. So in the code generation, generator again takes the IR, means optimize code as an input and generates code for the target machine. As we all know, our output of the compiler is a machine code, that is target machine for a particular machine. Here the detail of how various numeric and non-numeric quantities are represented become important. Just like this is totally machine oriented, so these are some terms belongs to a particular machine. Just like word length, hardware stack, hardware calling, etc. Now come to, and this is target code optimizer. Just like target code optimizer examine the emitted target code to see if further possibilities for optimization are present and then capitalize upon them. Just like reuse of registers, using a shift instructions to replace a multiplication and division, so on. So now we can say by block diagram, source program, first phase, that is lexical analyzer or scanner. It will produce tokens. These tokens will be the input for next phase, that is syntax analyzer, and as an output it generate parse tree. It will treat as an input for next phase, that is semantic analyzer. It will generate abstract syntax tree with attributes, or we can say annotated parse tree. Just like take a simple example. Suppose we have given a code int a, this one. So as a source program lexical analyzer, it will generate tokens. Tokens mean just like tokens are the entities defined by the compiler. These are definition of tokens. Just like single characters operator, just like this one addition operator, and more than one character operators, multiple symbol operator, that is increment operator, decrement operator. Numeric constant, these are the fixed value. Keywords, these are the predefined words of any programming language. In C we have integer, while, for, these are some common keywords. Identifier, suppose we have X, my name, you, name. Identifier, as we all know, is a combination of constant and, it's a combination of alphabet and numbers, but must be start with any alphabet, just like this one. So we, in the given program, we have token, first is int, type is keyword, then a, it is an identifier name, then comma, it's a separator, and then we have b, it is also identifier, then we have parenthesis, then again identifier, then this is bracket, then we have equal operator, assignment operator, then we have a fixed value, that is integer, or we can say constant, then delimiters, that is semicolon, then another identifier, this is f, it is also name of identifier, then plus operator, and then we have 3 as a constant value. So these are the number of tokens. So total we have 14 tokens in that. So this is the required parse tree that generates. You can generate this a, this one, statement 1 to this one. You can easily find this. Now this is going to convert in next intermediate representation. This is what. First we save this into temporary variable t1, then store t1 to a, and this is simple 3 address code generated. Then reducing, or we can say eliminated unnecessary code to make that code optimize, and after that we are getting the final target code. that is machine code for that particular high level example, a high level program example. This is all compiler and lexical analysis, semantics, these all are. Now we have construction tool by means each phase. First phase is scanner. So scanner generator will be the compiler construction tool. In the same we have second phase parser. So it is another construction tool, that is parser generator. In the same manner we have syntax directed translator engines, automatic code generator, data flow analysis engines, compiler construction tool code. These are some commonly used compiler construction tool. In the first case, it generates lexical analyzer from the input that consists of regular expression, description based on the tokens of a language. Common is lex. Example of scanner generator is lex. And then we have parser generator. It will generate parsers. So from the input means we can say from the input that is based on grammatical description of programming language, or we can say CFG, context free grammar, useful as the syntax analysis phase, highly complex. Example is PIC EQM. Then we have syntax directed translation engine. So these will be the generated annotated parse tree that we'll discuss in the last example we are taken. It generates intermediate code with 3 address format from the input that consists of a parse tree. These engines have routines to traverse the parse tree and then produce the intermediate code. In this, each node of the parse tree associated with one or more translation that we will do into float in our example. Then we have automatic code generator. It generates the machine language for a target machine. Each operation of the intermediate language is translated using a collection of rules and then it is taken as an input by the code generator. A template machine process is used. An intermediate language statement is replaced by its equivalent machine language statement using template. So we have number of templates through which we convert the previous output, that is annotated parse tree, into code, initial code. Then we have data flow analysis engine. So that is data flow analysis is a key part of the code optimization. So whatever we get in the previous code, we are going to optimize that and gather information that is valued that flow from one part of the program to another part. Then we have complete construction toolkit. It provide an integrated set of routines that help in building compiler component or in construction of various phases of compiler. So this is all about this one. Thank you very much.